To start, here it is, the multiplication table, the foundation of elementary math. But look closer, this is not just a grid of answers, it's a map that will bring you more. This table holds the key to understanding factors and multipliers. Let's take a number, let's say 12. Where do you see 12 in this table? Each time you see 12 is because two numbers multiplied to make it. 1 times 12, 2, 2 times 6, and 3 times 4. These numbers 1, 2, 3, 4, 6, and 12, they're called the factors of 12. Think of factors like building blocks. They're the pieces you put together to build a number. And what's the building? The number itself. So 12 is the building, 1, 2, 3, 4, 6, and 12, they're the blocks to make that building. Now that we've seen how factors are like Lego blocks, it's time to look at the buildings we can make with them. Let's go slow here. This part is really interesting. If factors are like Lego pieces, then multiples are like the many different buildings we can build using those pieces. Let's say we have one block, the number 3. Now imagine you make one building with it. 3 times 1 equals to 3. Then you build another, a taller one. 3 times 2 equals to 6. Then another 3 times 3 equals to 9. 3 times 4 equals to 12. 3 times 5 equals to 15, and so on. Each time we're building something new with 3, and each of those results, 3, 6, 9, 12, 15, are called multiples of 3. And let's look at the multiples of 6. 6, 12, 18, 24, 30, 36, 42, and 48, and so on. Multiples of 4, 4, 8, 12, 16, 20, 24, 28, and so on. So while factors are limited, only so many blocks can build a number, multiples are unlimited. So you can build infinite things with them. It's now your turn. Give me 5 multiples of 5. Now let's go back to the idea of blocks. What if I hand you a building, say the number 24, and I say break it down into the blocks used to make it? That's called factorization. It's like reverse engineering the structure. So you look at 24 and say, 6 times 4 equals to 24. Good start. Then you go further. 6 can be broken down to 2 times 3, and 4 can be broken down to 2 times 2. Now you've reached the most basic tiny building blocks. 2 times 2 times 2 times 3 gives us 24. You've just factorized 24. Let's try another example. 18. So 18 equals to 2 times 9, but 9 equals to 3 times 3. So 18 equals to 2 times 3 times 3. It is your turn now. Factorize 36 into its tiniest building blocks. Before we get into prime factorization, we need to understand what prime numbers and composite numbers are. A prime number is a special number that has exactly 2 factors, just one and itself. No roommates, just a number and its mirror. Examples: 2, 3, 5, 7, 11, 13, 17. That's the prime squad. And by the way, 2 is the only even prime number. Every other even number already divisible by 2. So 2 is kind of the VIP here. Now, what about composite numbers? A composite number is just a number that has more than 2 factors. Take 12 for example. It has 1, 2, 3, 4, 6, and 12 as factors. That's more than 2. So 12 is composite. Let's try another example. Is 9 a prime? Nope. It has 1, 3, and 9 as its factors. So it's composite. What about 7? Only 1 and 7 are the factors of 7. So that's a prime. So
and future or faced anything like this.
here's the key idea. Prime, exactly 2 factors. Composite, more than 2 factors. And now, with that locked in, let's go deep into prime factorization, using only these prime warriors to break down any number. Prime factorization is when you break a number down to its prime building blocks. Let's take 60 for example. 60 equals to 6 times 10, and 6 equals to 2 times 3, and 10 equals to 2 times 5. So we can rewrite 6 times 10 as 2 times 2 times 3 times 5. If you noted, all these 4 numbers are prime numbers. So what we did here is called prime factorization. Every number can be broken down into prime numbers. That's the beauty of it. And what's even cooler, no matter how you break it, you'll always end up with the same prime factors. But let me clarify with an example. So I said 60 equals to 6 times 10, and then we broke it down to 2 times 2 times 3 times 5. Now, if I said 60 can be also written as 15 times 4. Now, 15 and 4 can also be broken down. 15 can be broken down to 3 times 5, and 4 can be broken down to 2 times 2. Again, we got the same prime factors. Again, if we use 30 times 2 equals to 60, 30 can be broken down to 15 times 2, and 15 can be broken down to 3 times 5. Again, we're left with the same prime factors. As I said, no matter how you break it, you'll always end up with the same prime factors. Multiples are the echoes, and primes are the unbreakable atoms of arithmetic. Math isn't just numbers, it's a story, and every number has a past, a future, and a role to play. So the next time you see a simple number like 12, pause, look closer. You might just uncover a universe. Thank you so much for following along. See you next time.